to Wednesday's edition of Cracking the Cryptic, where I'm hoping we're in for a shorter video than yesterday. Those of you who joined me on my epic trail will know that last night's video, well, the puzzle, Glipperal's Balance Loop Sudoku, took me 2 hours and a quarter to solve. It was very hard indeed. Absolutely wonderful puzzle. Do have a go if you have, well, at least an hour or two to spare, I'd suggest. And yeah, it was an amazing experience. I was going through the comments though last night, and some of you noticed that when I was going through an example in the puzzle, I'd left in a loop segment that wasn't justified logically. So I released a little bonus video this morning. It's only 5 minutes that deals with that point. So if any of you were struggling to follow why that loop segment was in the puzzle, you can go and check out the video now, and that should put your minds at rest. Anything else to mention? Well, I should talk about, well, I've said this puzzle is meant to be easier. What is it, and why is it bigger than normal? These are good questions. It's called Deconstruction, and it's by Jay Dyer. Now, I only did a puzzle by Jay just the other day, and that was a wonderful normal looking Sudoku. In fact, I better not say how it resolved in case any of you haven't done it, but it was a quite fascinating idea. And yeah, well, this one's been recommended as a good follow-up to last night's video, which I presume means that it's going to be easier. And we'll talk about the rules in a second. I have just read them through before I turned on the webcam, and they are quite unusual. The only other bit of news I've got to mention though is that I have scheduled a stream at long last. So loads of you have been asking when we're next going to stream. Well, it's going to be Saturday night, 10 PM UK time, and we're going to be trying this game here, which is called Escape Simulator. I'm really looking forward to trying this because apparently it's like a real life escape room, but you get to do it virtually. So yeah, we'll see how this goes, but it should be a lot of fun, and we'd love to have your company if you have time to join us. Now, I think there's nothing else, so let's get on with the rules of deconstruction, and they are as follows. Contained within the grid are 9 non-overlapping 3x3 square regions, which must be located. Each region contains the digits 1 to 9 once each, such that no digit repeats in any row or column of the grid. Okay. Cells outside regions do not contain digits. The digits in each cage sum to the clue in the top left corner and may not repeat. Cages may include cells outside regions. Now, I think it's that last line of the instructions that really make this a bit of a head scratcher, because what it sounds like we've got to do is basically let's use some colors to do this. We've got to position the 3x3s within this grid all over the place, wherever they may be, but there are going to be 9 normal-ish 3x3 boxes that each have to contain the digits 1 to 9 once each, such that if we worked out this square was a 1, for example, we couldn't now put a 1 in this 3x3 box in any of those 3 squares, because that would repeat the 1 in the column, and we mustn't do that. Now, the rinky-dink here, I mean, if that's not enough rinky-dinks already, is that these cages, well, the digits in the cages do have to add up to the totals. It tells us that. So let's look at this 21 cage for a moment. This 21 cage has digits in it that sum to 21. In fact, this is a good example of how this could work. In fact, it's a good example of showing why this pattern cannot work. I've got to move this purple thing around. And the reason I've got to move it around, let's put it there instead, is that this cage has to add up to 21. But where I had that purple 3x3 before, I couldn't have fitted another 3x3 in this, so I'd have had to make those 2 cells add up to 21, and that's not possible. So here, this might be a possible arrangement of the 3x3s, but it's not necessary for this cell here to contain a digit or be in a region. So it could be the case that this 21 total here is just adding those 3 cells up. So similarly, I suppose it's true to say that there may be no 3 by 3 region overlapping this 9 cage here, so it could just be that that's a 9. And that cage would be full now, and these two cells would not be in regions. So we're going to have to identify like a colour for digits that are, well, blank cells. So it's a fascinating idea. I can tell you that the most common adjective used to describe this puzzle on Logic Masters Germany is fun. And I can also tell you that it has got praise from none other than Phistomefel himself, who thinks it's a very, very good Sudoku puzzle. So if my recommendation isn't good enough, believe Phistomefel. He knows a thing or two about these things. Do have a go at this. The way to play is to click the link under the video as usual. And now I get to play. Let's get cracking somehow. I suppose my first question actually is, how big is this grid? 6, 7, 8, 9, 10, 11. And it is square, isn't it, I think? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's an 11 by 11 grid. So that means it's got 121 cells in it. Now, we have to position 9 3 by 3 blocks. So that means the 3 by 3 blocks that we position will consume 81 cells. So there are exactly 40 cells in this puzzle that are unfilled. Now, where do they go then? Can anyone tell me? Let me think about this. So low cage totals. Yeah, low cage totals are very, very, I was going to use the word unuseful, which I appreciate it's not a word at all, but they are fairly annoying, aren't they? Because we don't know. Well, what do we know about this 4 cage? We know one of its digits, at least, must be a real digit, and therefore in a 3 by 3, because we can't leave both of these out, or the total for the cage would be 0, and that's against the rules. But we don't know whether it's one cell in this cage adding up to 4, or it's 2 cells in the cage being a 1-3 pair. Whereas, looking at this 18 cage down here, that must be full of digits. Because if it's not, you'd have to, if you try and say that this cell doesn't contain a digit, then those 2 cells would both have to be 9s, and that won't work. So in fact, we can immediately label these cells as being digits. Now, if those are digits, that means that because this cell is part of a region, we can draw a 3 by 3 off the back of that. So there we go. We've actually started the puzzle. That is a 3 by 3 region, and therefore every cell that I've just drawn contains a digit, which means that that's a 1-2 pair in the 3 cage. Now that, yes, okay, well now this is already very interesting, because now this 4 cage can't be it can't have both its digits counting, or it would be a 1-3 and there would be a clash of 1s in the row. So that is not a digit, which means that is a digit and must be a 4. Now, this is already very interesting. If this is not a digit, how could this ever be in a 3 by 3 region now? Well, it can't, because the 3 by 3 region would dip underneath the grid, and that's ludicrous. So those 2 squares are not in 3 by 3 regions now. Now we've got this cage. Now I'm looking at the 3 cage and wondering how that's going to work, because that cannot now be 2 cells, can it? Because if it was, it would be a 1-2 pair, and then that would clash. So there is exactly one of these cells is a 3. Yeah, hang on, it can't be, yeah, what it can't be is the bottom one is a real digit and the top one is not a digit, because this one is not now capable of being in a 3 by 3. So it must be the other way up. So that's orange and that one's blue. And if that one's blue, surely the 2 cells are, we know it's a 3 by 3 of some sort, so we can do that. And do we know the 21 cage must be at least 3 cells, because we can't put like 10 and 11 into those cells. But that, does that mean, no, it doesn't. I suppose what you could have, in fact you could have loads of different things. You could have like a 3x3 region over here, and then a 3x3 region like that, and this cell being left out. So we don't yet know what this means, but we do know that digit's a 3. We know this digit now is incapable of being 3x3'd, so that comes out. These cells here in this 2x2 in the corner now can't join 3x3s, so they get annihilated. Now we've got to put a digit in the 8 cage, at least one digit. Yeah, okay, so we can't, it doesn't, well, sorry, I'm being completely inarticulate, but I'm trying to get my head around whether it's possible that only one of these digits is in, and it's not, is it? It's not possible that only one of those 2 digits is blue, because if that's the case, you can't put them in a 3x3. You're going to have some weird shaped region going up here, or you're going to have to create a very strange box like this, and that's nonsense. So both of those must be in, and that means the cell above must be in. Now, does that mean... No, okay. So this cell now, or maybe this 8 cage, because we know that these 2 cells add to 8 and they're not 3, 5, so they're either 2, 6 or 1, 7, and that square can't be a 1 or a 2, so that square can't be a 6 or a 7. It's very weird seeing these not aligning, I have to say that. So where do we look now? We can... I really want to finish this one off. I suspect it's going to go this way. So the 21 cage would then contain 4 cells. But I can't prove that. Oh, 30 cage, that can't be missing any digits at all. Because if one of these was not in a region, the other 3 digits would be a maximum of 9, 8 and 7 and only add up to 24. So they all get bluified. 14 must be bluified, because I can't make one of these cells a 14 and the other a 0. That's silly. 13 must be bluified. Hang on a moment. Can't see any others. No, I can't see any others. So I'm just trying to think, what does that mean for these other cages? In the other cages... This 18 cage must have at least 3 cells that are digits, mustn't it? So there must be some digits in the top row that are real. But I suppose it could be that one joining to a region over there. We don't really... I don't think we really know much about that. So we shall now look for something else. The 30 cage must be 6, 7, 8, 9. Just wondering if it's possible to argue that, well, clearly the 30 cage can't overlap now, but it couldn't anyway. I couldn't draw a 3x3 around the 30 cage that encompasses either all of the 14 cage or all of the 13 cage. So how do we do this then? Oh, the 13 cage has got 4 in its column, so it's either 5, 8 or 6, 7 now. Phone is buzzing as usual. Okay, so where do we look now? The 6 cage here must have a digit in it, so surely that has an implication for bluifying this 3x3, doesn't it? So if this was a digit, then that would have to be a digit. Yes, okay. So this, right, so let's look at the 6 cage. And it could be just a 6 on its own, or it could be a 1-5 pair or a 2-4 pair. But I think the interesting thing is it's not possible for this not to be a digit, Because if that's not a digit, that must be a digit but could not be part of a 3 by 3. So that is definitely blue. Does that mean yes? Okay. And now how do you put this in a 3 by 3 without including that square? You can't do it. If this was really orange, this couldn't be part of a 3 by 3. So that's blue. That's in a 4 cage. So what does that mean? Does that mean that can't be a 4 on its own? So that must be a 1 or a 3, presumably. There must be, yeah, I suppose what we're learning here is that in this 4 cage, it's not possible for this just to be a single digit here that's equal to 4, because this has definitely got to contain a digit and cannot itself be a 4. So there is a 1-3 pair in this 4 cage, which is either here and here or here and here. Okay. I have a horrible feeling that I should be able to tell which of those is more likely, but I can't see how to do it. So can I conclude something about this? If this was a 2-cell 6 cage, there would be a virtual 1-2 pair in the column, because there must be a 1 or a 2 in a 2-cell 6 cage. What about, is that really possible? Might be possible. So every other cage in the puzzle must have at least one of its digits bluified. That's a bit weird, isn't it? I'm not actually sure how to do this. I'm not sure whether what I'm meant to be doing is sort of almost shading in every cage and then trying to template over that shading 9 3 by 3 regions, and whether that's in any way whether it's difficult to do that. It doesn't look like it will be difficult to do that. Or can I do more Sudoku somehow? We could, hang on a minute, I'm not sure what to do here. We could, 10. This, what's that digit then? That can't be a 10. I've got to put at least 2 cells in this 10 cage. Is that helpful or not? Oh, can I do maths on this box? That's probably a good idea. I've got those 3 squares adding up to 7. Those 3 squares adding up to 18. So that's 25. We know from the secret. And if you don't know the secret, where have you been? I only tell it to my favourite people, but I do say it often. The secret is, of course, that any complete 3 by 3 box of a Sudoku will contain all of the digits 1 to 9 once each. If you add those digits up, you get 45. So if I know that those 6 cells add up to 25, those 3 cells add up to 20. Which might be useful, but I'm not sure is. Oh, I tell you something I hadn't thought about, but what about the fact that this can't itself be a 10 means one of those 3 cells must be a blue cell. At least one of them, possibly all 3 of them. Or no, actually not all 3 of them, because that square would then not have a fill. If this was a 4-cell 10 cage, that square couldn't be filled now because it sees 1, 2, 3 and 4 in its row. So, right, I see. So we can actually do some bluing here. If this is blue, let's think about the implications of that. If this is blue, the 3 by 3 region it's part of must take those 6 cells. It just must. the same is true of, well, it's not quite the same as true of this one, but if this one is blue, that one is still blue, because we've got to fit a 3x3 region around this, and you'd have to take those squares. So actually, we don't know which of these cells is blue, but we always know this is blue. Because if either of these two are blue, you have to blue this. And we know that one of these three at least must be blue. So that's always blue. And that can't be that low a digit. So that cell's got to be... Hang on, that cell's got to be a 3 at least. So if this is 3 or 5, 6 or higher, 5, 6, no, it can't be 6, can it? Because if it's 6, this is at least 5. No, it can't be 6. In fact, can it be 5? If that's 5, no, it can't be 5. If that's 5, that's at least 5, and this cage is adding up to more than 10. That is 3. So this square has to be 7 or less. But it can't be 1, 2, 3 or 4, so that's 5, 6 or 7. This 3 is seeing that cell up there. Ah, now the 4 cage, look, that square is not in. Because we know the 4 cage is a 1, 3 pair, and this cell can be neither. So that's oranged. That's orange as a result. You can't fit a 3x3 in a 2x2, so all of that turns orange, and that square's a 3. That's lovely. This square is now forced to be a 6 because it's the only cell in its 6 cage. Oh, now, well, that means that's a 6, and surely that's going to have implications, because now I can't tie this into the same region as this. This is beautiful. Good grief. Right. So, how is this part of a 3x3 region that does not include that cell? It must be that. So that is all bluified. And now what I'm wondering actually whether to... Is it worth checkerboarding or pen tooling this? I got into trouble with pen tool. I'm going to checkerboard this, I think. Let's make those green. I hope that's not going to offend anyone's colourblind sensibilities. But these squares here must all be digits, and they're in a different region to this region. Oh, and look, that can't be 6, 7 now. So that's 5, 8. I'm not sure what that means, but yeah, but this is still good, isn't it? Because this being, oh, is that green? Oh no, I might have made a mistake here. Sorry, I'm going to unwind this. I'm not happy with that. I'm happy with this being a blue region. That is true. I've changed my mind. I'm going to go back to the pen tool. I think it's going to be less prone to error. That is a region for sure. But what I've just had a horrible thought about is what happens if it's that that's the region, or even that that's the region. Why is that not possible? I don't know. Bother. So although this 30 cage is so difficult to get your head around, or at least for me, although the 30 cage is all in the same cage, a bit of a tautology, but it's not necessarily true that these are all in the same region. So when I coloured those in green, that was not valid. But that square is blue, that's true. And in order to get this into a 3x3, that square must be blue. And similarly, that must be the same with this. These two squares must both be blue, mustn't they? Otherwise this can't be in a region. So that is true. This is part of a region, this is part of a region, this is part of a region, but we don't know. Well, we know that these are all in the same region, I suppose, because they cannot not be. But that's going to get really complicated if I try. I don't know how to do this at all. Maybe I'll give those a green flash to say these are in the same region, but it's not necessarily the same region as this. So that square is in the same region as a 7, 8, 9 triple. So that square has got to be a 5 or a 6. That square has got to be an 8 or a 9. Yes, and I suppose the corollary of that is that that is forced as a divider, isn't it? Because this is part of its own 3 by 3, and that cannot be part of the same 3 by 3. Wow. Okay. What does this mean? Oh, I've got to redo that logic again. So this is now a 5/8 pair. I keep seeing this 6 as being part of this. It's so difficult not to. Okay. Actually, I could draw that line segment in as well, although it's not going to help me with the issue that we've just come up against. Oh, this 5 then, how's that going to work? This must be blue, mustn't it? Ah, that's beautiful. Yeah, it is. This must be blue, because at least one of these squares must be blue. And it can't be this one being orange, because if that's blue, it can't be part of the 3 by 3. So that's blue. But now what is exactly are its options? It can't be 1, 3, 4 or 5, so it must be a 2, and that means that one is forced to be a 3. That's really clever. So now all of these have to be part of a region, and that region is definitely different from that region at the bottom. So probably we can green flash this, and does that help us to learn about the ways of the world or not? The answer seems to be no. Because I suppose this is either joining to that or to that, and we don't know which. Ah, but that 14 must be, the left-hand cell of the 14 cage must be in a 3 by 3. So all of these 6 cells must be blue now. And again, we can wall off those. Ah, now, hang on, now Sudoku's going to be our friend, because how do we fill this 12 cage? If every one of these digits has to be filled, and we can't use any high digit, that has to be 3, 4 and 5. That's the only way that will work. Oh, and look now, we've actually filled in all 9 cells that could ever exist in row 3. We can't have 10 cells in row 3 or there'll be a repeated digit in the row, and that's against the rules of the puzzle. So that's a 2, which means that's a 2 and that's a 1. I don't know what that means beyond that these 2 squares have to now be oranged. Oh, yeah, this is important though. This 2 by 2 is now isolated in the top of the grid, so that's not. These 2 squares in the 15 cage now have to both be real, and that means that square's got to be real, and that's absolutely enormous, because this is part of its own region. So this is a 3 by 3 we've just discovered out of absolutely nowhere. This here has to be a 3 by 3, because those first 2 cells in row 4 had to be real. Oh, and now I'm going to have trouble with my checkerboard. No, I'm not going to have trouble with that checkerboard. If I give that the green flash, that will work nicely. But this is also, look what it's done to this region in the top of the grid. That's now forced to be a region. There. So now, can you actually have a 5-cell 18 cage? You can. In fact, that almost looks likely, doesn't it, given we've got so many high digits already consumed. We could easily put low digits in there, and we could put low digits in there. This 8 cage is not 3, 5, so that's either 2, 6 or 1, 7. Ah, you can't fit a 2 by 2, a 3 by 3 in this little region here now. So this line segment which I drew has actually been useful, because I can orange those in. Now at least one of the 8 cage must be in. Yes, okay, and if it's this one, that one's in as well. So this is always blue. Now, so hang on, that feels like it's doing something to me. Because if that was a 3 by 3, you'd now have to fill in all of those as being blue to make a 3 by 3 out of this cell. Or if that's a 3 by 3, then that's a 3 by 3. So you always have to put this cell in as blue as well now. Ah, what's that cell? That's 9. That's just filled in. It's the only cell in its cage. And these two cells have got to add up to 15, and they're not 9, 6, so they're 7, 8. Which means that squares a 5 by our old friend Sudoku. We get a 5, 8 pair over here. Now we can do some Sudoku here as well. Where does 7 go in this box? There must be a 7 in it. It's not in those two squares, and it can't be in the 9 cage now, because if it's in the 9 cage, that would need to be a 2, and it can't be. So that's a 7. These square. Oh, where does 9 go in this cage now? It's got to go here, and that's beautiful, because that means this square is not filled, which means these two squares are not filled, which means these two squares are filled and get a green flash. Wow. Oh. No. Well, how can this square now be blue? It can't be. If that's blue, it's creating a 3 by 3 region, okay, but this region up here would only be a 2 by 3, and that's no good. So that's orange. And that's, yes, and that's beautiful because it's creating a corner around this 6, forcing that to be a region and giving us more orange in the top of the grid, look. I've just seen a line segment I could put in up there, so I'm going to do that. Now this 8 cage, not 8 cage, but this 8 region must come down to here and must take these 2 cells as well, 3 cells as well. And yes, and this can't be a 9 on its own because we've already used 9 in this box. Those get green flashed. But this can't be a 9, so one of these 2 must be in. But if one of them is in, surely they're both in, aren't they? If that one's not in and that one's in, you can't put it in a 3 by 3. And if that one's in, that one's in. Yes, this 9 cage is actually replete. It's got a full complement of digits, which means that must be in, otherwise it can't make a 3 by 3. And there we go. We've got some shape in the middle. We've got this shape on the right. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I have approximately worked out where my 9 regions are. We can do some more oranging. Those cells have now got to be orange. This is a quality puzzle. And the other thing I'm thinking is this is a quality puzzle that I think, you know, there could be more of these puzzles. I think this is so unusual and interesting. I'd love to see it. I'd love to do another of this. It is indeed fun. That 6 is in that same region as that, look. So that's got to be a 5 now, which means that's a 9. That's the world's most useless 9, though. It doesn't seem to do anything. Oh, I tell you what's weird as well. I was looking along here thinking, well, where do I put the 8 in this row? But there might not be an 8 in row 2. Indeed, there isn't an 8 in row 2. Okay. Oh, if they're both in, they've got to be 1, 4 pair. So this 8 cage is either 2, 6 or 5, 3 in that order. Okay, now what do we do? We must surely be able to... Yeah, okay, this cell being in now requires this cell to be in, otherwise this can't be in a 3 by 3. So that cell's in. So I've now... Ah, this is huge. Right, so now let's think about whether this cell can be in. And the answer is no, because we've already looked at this. If 4 cells of that 10 cage were in, You'd have to make them 1, 2, 3 and 4, and we know this can't be that. So that's out, which means that's out, which means these, for this to be in a region, all of these have to be in a region, which amongst other things I can see means that this is now a line we can draw in the grid, because this can't be part of that region. And that means that I can draw in more cells over here. Oh, beautiful. Right, and now how do we finish this 21 cage off? This cell can't be in. I think I could have done that before, it couldn't have been reached. But that means that cell's got to be in, because otherwise we have to make 2 cells add up to 21. So that's another region. And now I can outline all my regions, and I think it might be in our interests to checkerboard it so it looks a bit cleaner. So now I'm going to get rid of all of these cells and make them green. Now, do I want to get rid of the orange now? No, I don't want to get rid of the orange, because the orange is telling me useful things, like that this square here is not got a digit in it. So we should now just be able to fill the puzzle in. Or is that wishful thinking? The 21 cage, can it have a 9 in it? Only if it's here. No, okay, sorry, that might not be sensible. The 10 cage, that can't be a 7 anymore, because this has to be a real digit. So we're either looking, oh, in fact there's a 5 looking at this. This is a 6. It's just forced to be a 6 and a 1. 6 plus 1 plus 3 doesn't equal 10, so that's a 1 and that's a 4. This 6 is telling us that's a 7 and that's a 1 now. That 7 is quite useful, so that's a 7 and that's an 8. Okay. And then for our next trick we will do what? We will, well, I've got to put 1, 2 and 4 into that region there, and I've got a 1 and a 4 looking at this square, so that seems to have to be a 2. This must be a 1, 4 pair then. That's in the 9 cage. So the 9 cage can have one of 1 and 4, but not both. Which I feel like that might be, oh, that can't be a 6, look, because of Sudoku. So that's not a 6, that's not a 2. And okay, where's the next easy deduction here? We've got to put, see, some of these rows are interesting, like this row we can treat as a normal Sudoku row. I've got to put 1, yeah, what are those squares? I've got to put 3 into that box. That's a 3 and that's a 4. So that's a 1 and that's a 4. And that means our 9 cage needs 8 more that aren't 1, 7. Okay, so this is also either a 2, 6 or a 3, 5 combo, and it joins with its friends there. So these squares have got to be 7, 8 and 9. Whoops, that was the world's worst piece of typing. And that means we've got a 4 here in the 18, 4 in an 18 cage. These two squares have to add up to 14 without using 9. So that's got to be a 6 and an 8. 6 comes out of that 8 cage and we get 1, 7. And this square must be a 2 in the corner to complete this region. Where does 2 go in this region, down at the bottom? I think by Sudoku, I think it has to be there. That puts 4 in here by Sudoku. That's impacted the 21 cage, which now, yeah, these two squares have to add to 17. So they have to be 8 and 9, and there's a 9 looking at them. So that's 9, that's 8. The remainder of this box is 5, 6 and 9, I think, which means we can't put 9 at all in the 14 cage, because 9 plus 5 would require a 0 here, and that won't work. So that's got to be a 5, 6 pair. This is a 9 in the corner. That square is a 3 by maths. That's not a 3, so that's not a 5. 8 is looking at this square. Now, can we keep this going? That felt like a flurry of decent activity for once. 9 is not in that square, look, by Sudoku. 3 and 4 are looking at that cell, so that's got to be 5. This column, look, has got all its digits in. So we know that those squares have got to be 1, 6, and... so where does the 7 go in the column? That's a good question. It's got to go there. And these squares have got to be a 1, 6 pair. Which means these squares have got to be 2, 4, and 5. You can see we can now place the 2. The 2 is lovely. That gives us the 3 here, the 5 here. So those squares have now got to be a 2, 6 pair, and we can do the order. So the 9 cage became 1, 6, 2 in the end. That 6 gives us a 6 and a 1. That 5 gives us the 5 and the 4. This row is now done. This row is now done. And can we do anything else easy? 5 is finishing the 5 and the 6 there. So we're sort of making progress. And, oh, what about that? That's a real column, look. That's got to be a 7 or an 8 then. And this is a real column as well. So we can do Sudoku down this column. That's got to be a 5 in this domino. This has got to be a 7 or a 9 by Sudoku. I don't know where to look. Maybe this column. Oh, we've got an 18 cage down here. Oh, good grief, yeah, let's come back to this. Those 3 squares had to add up to 20, didn't they? I've got a 3 in them, so they've got to be 8 and 9, and there's a 9 here. So that's a 9, that's an 8. These must be 5, 6, and 7. That's a 5 by Sudoku. It's quite strange, actually. I can imagine in setting this puzzle, it must have been tricky at some points to know that this would solve uniquely. Those squares have got to include a 1, and you can see that there's got to be 1 here, therefore. And there's got to be a, what's the other digit? We're missing 8. So that's a 7. Now, can we do the same in this column? We've got to put 6, 7, and 9 in. So this is a 9 and 7, so that's got to be a 6, and that actually does resolve all of that business at the bottom. That's now a 9, that's a 7, that's 8, that's 7, that's 9. Therefore this is 7, this is 8. These squares they're not determined by the column, only their box, so they've got to be 4 and 5, which we can do. And we've just got this, and this box to do. And we've what do we know? We know that digit, that's a 3. So that's a 3 and that's a 4. So now let's maybe have a look down this column where we need 2, 6 and 8. Oh, so where does 6 go in the column? It must just go at the top. So 6, 8. 2 must go here, 8 must go here, and these should be 4 and 5. Now, how on earth are we going to tell whether this is correct? Will the software do it? I don't know. No. Oh, it's made it look beautiful with the sort of red. I think it's saying that the red cells are wrong, but that's not true software. Although I don't blame you for not understanding. So I think the only way we're going to be able to do this, well, I'll probably do it during editing. I will stare at this and convince myself whether I think it looks right or not. And if it looks right, you'll see the video. And if it doesn't look right, you never will, I'm afraid. But I'm staring at it now. I think the cage totals look like they add up. And I haven't spotted a box that's got a repeated digit in it. So I hope this is correct. That was great fun. It was fun. It wasn't as hard as yesterday, but for all that, it had an awful lot to commend it, didn't it? It was just a very original idea, and I think, as I said, that we could see another one of these. So Jay, thank you very much for setting something so enjoyable. I hope you enjoyed watching, and we'll be back later with another edition of Cracking the Cryptic.